In this video, we are going to talk about magnetic declination and magnetic bearings and how to calculate a true bearing based on a magnetic declination. So for this sample problem that I'm looking at here, we are assuming that the magnetic declination is 4 degrees east, or north 4 degrees east would be the magnetic bearing of this line. So this red line is showing magnetic north in a particular area, and I guess the rest of this is our cardinal directions. So here's my north arrow pointing straight up, true north or grid north, and then here is the line showing magnetic north, or our magnetic declination. So in this particular problem, our declination is 4 degrees east, or north 4 degrees east. So here is magnetic north, and you can see it is 4 degrees to the east of true north. So a declination is describing the relative angle between the magnetic pole and the true north. We're in the northern hemisphere, so that's how our declinations are described. And then you'll see a lot of sample problems that say, well, the magnetic bearing of a line is some bearing, or in this case, the magnetic bearing for some line is 10 degrees 24 minutes east, or north 10 degrees 24 minutes. And let me just throw a label on that line. So I'm going to pick my line and curve and do a bearing only. So here is the bearing. Now notice how the bearing, this is showing the true bearing, not the magnetic bearing. So the magnetic bearing of this line is described from magnetic north towards the east or west if you're in the fourth quadrant, but here in the first quadrant we start at north, go towards the east. And if we're talking about a magnetic bearing, then that bearing is in relation to magnetic north. So again, here is magnetic north, and the magnetic bearing of this other line is north 10 degrees 24 minutes east. And that is describing the angle between this line in question and magnetic north. And notice the actual bearing, or the true bearing based on true north, is different from the magnetic bearing. In this case, we would add 4 degrees to our magnetic bearing to get the true bearing. As you can see here, there is more than the 10 degrees 24 minutes to get from the line in question back to true north. And so we have to add both of these angles together to get the true bearing. And then you'll also sometimes see a problem that says, well, this magnetic bearing was 50 years ago, and over the course of that time the magnetic pole has shifted, and so let's say now our magnetic pole is something like 0 degrees 25 minutes west. So let me draw a line by an angle. And so this angle that I want is going to be 0 degrees and 25 minutes. So I'll input that. Oh, I forgot I need to do a negative, so let me go back in here, line by angle. And then I need negative 0 degrees 25 minutes. And now let me change this color to red also. I'll just force it to be a different color. And this is very close together. It's only 25 minutes to the west of our true north line. But that is the new magnetic north. So the magnetic north has shifted over time. And now the question might ask something like, what is the new magnetic bearing of this same line in question? So we know the the actual or the true bearing based on true north of this line, but the magnetic declination or magnetic north has shifted. And let's say we need to calculate the new magnetic bearing of this same line. So what we would have to do then is take our true bearing and add to it this little bit of an angle between true north and the new magnetic north. So this little tiny sliver of an angle here, 25 minutes, if I add that to my my true bearing, I will get the new magnetic bearing for this line, which should be 14 minutes and 49, or I'm sorry, 14 degrees, 49 minutes. So let me check that here. I can do an angular dimension, and that's one way to find the angle between lines. And you can see here my new magnetic bearing is 14 degrees 49 minutes, 25 minutes different from the true bearing because we have 25 minutes of angle between our magnetic declination and our true north. So hopefully that was helpful. We can try a couple more of these in videos to come.